बिस्मिल्लाहिर्रहमानिर्रहीम. Dear students, आज हम बात करेंगे about the important topic, that is factors affecting degree of dissociation. उसके साथ में और एक important factor है जो basically एक factor है, but we'll be discussing it as common ion effect. ये दो important topics हैं जहाँ से you always expect questions, particularly in the competitive exams. So we'll begin with this concise series. So the factor number 1, factors affecting degree of dissociation or ionization. We have already discussed what actually you mean by the degree of dissociation. By degree of dissociation, we know that, for example, if we have an electrolyte, let's say electrolyte is a substance that you dissolve in some solvent, it gets dissociated into ions. Let's say this is electrolyte. Upon dissolution, so it gets dissociated like this. Any electrolyte. Sorry, this is A minus. Let's say this is your negatively charged species plus H plus. So this is some sort of acid. But anyway, it's an electrolyte. So by degree of dissociation, I can write. Now, if this is a weak electrolyte, or this, if it is a strong electrolyte, how can we say that? By simply looking at a term called as the alpha. So what alpha means? Let's say the number of molecules you dissolve. Now, out of those molecules, how many molecules will ionize or dissociate? So I should write the degree of dissociation is number of molecules ionized. Now just write it, number of molecules ionized or dissociated in a solvent divided by total number of molecules dissolved. Now the question is very simple, that if more number of molecules will dissociate, so the alpha will be very, very high. And the maximum value of alpha can be 1. That means when all the number of molecules will get dissociated once you dissolve those in the solvent. So जितना आप किसी भी electrolyte का value close to 1 आएगा, that means it's a strong electrolyte. और जितना कम आएगा close to 0.1, close to 0, so that means it's a weak electrolyte. Very less number of molecules have actually got dissociated. So this degree of dissociation, it depends on, number 1, nature of solute or electrolyte. Weak electrolytes dissociate less, strong electrolytes dissociate more. So simple. ये electrolyte का अपना एक natural एक tendency रहती है that, you know, if it's a weak electrolyte means it doesn't get dissociated so easily. At least number of molecules will get dissociated when you dissolve that in the solvent. So it depends on the nature of the electrolyte. If the electrolyte is weak, obviously the alpha value is very less. If the electrolyte is stronger, that means the alpha value will be high or close to 1. So number 1. Number 2, nature of solvent. Now this is very, very important question. Let's say what it writes, ionizing power of solvent. We know जब भी हमारे पास कोई electrolyte होता है, जब हम इसको dissolve करते हैं solvent में, its dissociation or ionization, it depends on the dielectric constant of the solvent. Now what do you mean by dielectric constant? Dielectric constant actually gives you the measure of polarity of solvent. The solvent की कितनी polarity है, that is expressed by dielectric constant. The moment you dissolve any electrolyte in the solvent, अगर वो जो ions है, if the ions are getting stabilized by the solvent, then obviously that solvent will help in the dissociation more and more. That means the degree of dissociation will be high. That will indicate the electrolytes are stronger. For example, I'll just put an example. If you have HCl, we know hydrochloric acid is a strong acid, so it's a strong electrolyte. That means alpha is 1. लेकिन ये जो हम strong electrolyte की बात करते हैं, it's actually with respect to the solvent. It's only a strong electrolyte or strong acid when you dissolve this in solvent like water, a polar solvent like water. So hydrochloric acid is a strong acid or strong electrolyte when you dissolve this in highly polar salt like water. Now अगर आप same hydrochloric acid को dissolve करोगे in non-polar solvent like carbon tetrachloride, so you dissolve this in the solvent like carbon tetrachloride, which is non-polar. Now the same HCl, it becomes a weak acid, it becomes a weak electrolyte, because your ions hai, they are not getting stabilized by the non-polar nature of solvent. Or you should say that the CCl4 has a low dielectric constant in comparison to water. One more example I can take, because this is very important. Let's say we have electrolyte, or we have electrolyte ammonium hydroxide. We know that this is a weak base. This is very weak base. By weak base means it doesn't give us hydroxide ions very easily upon dissociation, or I should say it's a weak electrolyte. Now ये जो weak electrolyte की बात कर लेते हैं, it's basically a weak electrolyte or weak base in the water. When you dissolve this in solvent like water, but if you dissolve this same ammonium hydroxide in the solvent like acetic acid, if you dissolve this in the acetic acid, the same ammonium hydroxide becomes a strong base. So the nature of electrolyte, dissociation of electrolyte, it basically is dependent on the solvent you use. So okay, so those solvents which can stabilize the ions of that particular electrolyte, that will help in the dissociation of electrolyte more. So degree of dissociation depends on the nature of the solvent also. Third point, concentration. The degree of dissociation, he writes, it's inversely related to the concentration. Now, एक important question यहाँ पे, how it affects. For example, if you have a strong electrolyte like HCl or sodium chloride, then it's a strong electrolyte. Obviously, this is independent of concentration. That alpha value has nothing to do with the concentration. But then what happens if you dissolve high concentration of sodium chloride in water? Remember this high concentration. It means जो ions आपके बन जाएंगे इसमें, the ions will be produced. Since the concentration is very high, so they will be very closer to each other, because there will be a lot of ions. So result is ये होगा, there will be always collision between the molecules. There will be always collision between the molecules because concentration is very high. So that what will happen? So that will actually affect the rate of migration. That will affect the conductivity. So the conductivity will go down actually. Like if we talk about weak electrolyte, let us say it's acetic acid. Now it's a weak acid, we know, so it's a weak electrolyte. Now if you dissolve this normally in water, we know it's a weak electrolyte, alpha value is very less, so only less molecules are dissociated. But if you use dilute solution, if you dilute the solution, means you use more amount of solvent, so what that will happen, that solvent will help in the dissociation. So basically the concentration for weak electrolyte, the degree of dissociation is basically inversely related to the square root of concentration as per the Osterwalder's dilute law. That means अगर concentration कम है, the degree of dissociation will increase. But this relationship is useful for weak electrolyte. So remember Osterwalder's dilute law, that degree of dissociation inversely related to the square root of concentration. It's related to the weak electrolyte like acetic acid, let's say ammonium hydroxide. So you can increase their degree of ionization or dissociation by simply diluting the solution, by minimizing the concentration. Next point. So degree of dissociation also depends on temperature. So ionization is directly proportional to temperature. How? जैसे ही आप temperature system का increase करते हो, for example this acetic acid solution, you increase the temperature. So what happens? The molecules will get the kinetic energy. They will get the kinetic energy. So उससे क्या होगा? They will overcome the intermolecular forces. Or you should say increase in temperature will help in breakage of that bond between the ions. Okay? So it actually supplies kinetic, the molecule gets kinetic energy, so that helps to overcome the intermolecular forces. So the degree of ionization increases with increase in temperature in general. So this was about the 4 factor. Now another important factor, factor number 5. This is very important. That is presence of other solutes. Means आपके पास एक electrolyte है. Let us say this is acetic acid. Let's say this is acetic acid is an electrolyte here. COOH. We know it's a weak electrolyte. Its degree of dissociation is less. It's closer to 0. No, it's a very less value. So now this point says that when other substances are present in the solution, other substances, some foreign substances apart from the acetic acid, that may affect the dissociation of electrolyte. So ये factor बोलता है कि there's a possibility that other ions, other substances present in the electrolyte solution, they can enhance the rate of dissociation. Let's take the example. Example is common ion effect. What does it mean? It means it describes the equilibrium that occurs when a common ion is added to the solution. यानी जब भी आपके पास एक common ion आ जाए solution में, a foreign particle, a foreign substance which produces a common ion to that which was produced by the electrolyte, that affects the degree of dissociation. Now, इसको understand करने के लिए let's go to the example. Look at this equilibrium. Our electrolyte is acetic acid. It gets dissociated to H plus and acetate ion. We know it's a weak electrolyte, so obviously the degree of dissociation is less. That means the less acetic acid molecules have got dissociated. Now, let us add the external electrolyte, that is sodium acetate. So हम sodium acetate को इसमें add करेंगे. Remember this. So when you add the sodium acetate, we know sodium acetate is a strong electrolyte. So I will write down the equilibrium here. This is your sodium acetate, CH3 COONA. This is our external electrolyte which we added. So that dissociates as per this equilibrium. It gives acetate ion. So it's the same ion, acetate ion plus sodium ion. I will just write down this by this figure. So this is acetate ion, CH3COO negative, and this. Now, जैसे आप देखोगे now जो ion produce किया है, let me write down the acetate ion to remove the confusion. This is what is produced, acetate ion plus obviously the sodium ion. Sodium ion. Now, जैसे ही आपने electrolyte external add किया sodium acetate, it gives acetate ion. Acetate ion is one of the ion which was also produced by the acetic acid. Now, this is called a common ion effect. You added external substance that produced an ion which is common to the one which was in the solution. उससे क्या होगा? Concentration of acetate ion is on the product side increases. Now, as per the Le-Chatelier's principle, the equilibrium goes in the backward direction. That means more acetic acid molecules are produced rather than the acetate ions. It means the degree of dissociation gets decreased. It gets suppressed. So I should say addition of acetate ion causes the equilibrium to shift to the left. That is, it decreases H positive concentration. So dissociation of weak electrolyte decreases by addition of strong electrolyte. This is as per the Le-Chatelier's principle. तो हमें ये पता चला कि in the common ion effect, it suppresses, it decreases, it brings down the dissociation of the weak electrolyte. Example number 2. Let's say we have a salt of sodium chloride, silver chloride rather. जैसे आप इसको dissolve करो, use silver ion and chloride ion. ठीक? Now to the same solution, if you add sodium chloride, इसी solution को आप sodium chloride add कर लीजिए. So sodium chloride will give, as per the ionization, we know it's a strong electrolyte. So it gives sodium ions plus it gives chloride ions. अब जैसे इसने chloride ion दिया, that now it becomes common to the one which was produced in the solution. This is common ion effect. So the chloride ion concentration increases on this side. That means the equilibrium will go towards backward side as per the Le-Chatelier principle. That means more silver chloride is getting precipitated because it's a solid precipitate and less ions are produced. So it basically suppresses the dissociation of silver chloride. Now to understand this ion, our common ion effect further, now let's look at this beautiful diagram. So what it says, it says that the effect of common ion on the solubility. यानी ये जो common ion effect है, it not only suppresses the solubility, it suppresses the dissociation, but also it brings an important thing, that is it decreases the solubility, it increases the precipitation. देखिए, ये आपका सिल्वर क्लोराइड सोल्यूशन था अभी जो हमने डिस्कस किया था. This is silver chloride dissolved in pure water. This is silver chloride dissolved in a solution which contains sodium chloride. Now remember this. So we have two glasswares here, two assemblies here, or two beakers. In one beaker we have pure water. This is pure water, and in that pure water we are adding silver chloride. And next we have a sodium chloride solution, and we are adding silver chloride. Now in this case, अगर आप यहाँ पे देखोगे, we will be having the common ion effect because chlorides are common on the product side. When the chlorides are common on the product side, that means the reaction goes towards backward direction. More silver chloride is produced, so that is more precipitate will be formed in this case. इसलिए आप यहाँ पे देख रहे हैं, in this case you can see here, this is more precipitate here at the bottom of this beaker, and in this case we have less precipitate. Why? Because we don't have common ion effect here. We have common ion effect here that decreases the dissociation, that internal increases the precipitate formation or reduces the solubility. So in nutshell, the solubility of silver chloride salt in pure water is greater. So pure water में ज़्यादा soluble, it gets more dissolved, more dissociated than it is solubility in sodium chloride because of the common ion effect. But remember this, we are keeping the temperature constant जब हम ये effect understand करने की कोशिश करते हैं. So this is all about our today's class, very important class regarding the effects, the factors which affect the degree of ionization or degree of dissociation, and also common ion effect, its effect on the solubility, precipitation and dissociation. So thank you. This is today from here. तो इसके अलावा भी ये जो मैंने points लिखी हैं इसमें I have produced this in the form of a small note. So that note is present in the description at the form of this PDF file. So you can see the link and download this. You can use it for the exams. In addition to this, अगर कोई question हो तो please write down back. So inshallah we'll try to cover it up. So thank you.